Hello there, this is Mr. Dunaway, and welcome to uh, Chapter 4, Section 4 it is, and there's actually an error right here. It's actually 4-4, and I wrote 4-5 on it, and I copied it, and then I realized afterward it's really in 4-4 where we are graphing absolute value functions. And the key to this today is that you can see some patterns between these 8 problems we're going to work together and identify a key point and see how the graph forms around that. If you fail to be able to identify that key point, life will be more difficult for you in graphing these particular functions. So let's start right away with number 1. I gave you some hints on the first side of the paper here. Number 1 just says y equals the absolute value of x. And we're just going to work through this together here. So I gave you values for x here. So if I took -3 and plugged it in for this x, and then I took the absolute value of it, that would just be 3. So that's the order pair, -3, 3. So let's plot that point, -3, 3 right there we go. And then if I did the same thing for -2, if I plugged that in there, I would get +2. And I'll just finish the table here. -1, well, no, I don't want to do that. I think I want to plot them as we go to show you what happens. -2, 2 goes here. -1, 1. Okay, that order pair -1, 1. 0, the absolute value of 0. So what I'm doing here is plugging that x into the equation there. And 0, 0 is there. Now watch what happens here. 1, absolute value of +1 is also +1. Absolute value of 2 is +2. Absolute value of 3 is 3. And notice what this graph just did. Now this would be true also if I had decimal values in here that would kind of follow along that pattern. So what we actually have here is this graph that looks like this. You'll notice all of the points are above the x-axis. And the reason that makes sense is that if you take the absolute value of a number, you could never get a negative value. So it makes total sense that my graph would look something like this. As you're doing this, I would appreciate if you'd use a straight edge to draw this line here. I could cheat and get my smart lines out, but that would take me more time. So what this is called, this particular equation, y equals the absolute value of x, that's the most simple form of an absolute value problem we can graph. So we call that a parent function. And what we're going to do is, as we graph the next few, we're going to compare how does the graph change when I do something like in number 2 when I add this +2. Let's observe what happens when I do that. Now we have a little more writing here to do, and I want you to get this in your notes. For this first value here, the equation is absolute value of x plus 2. That means we go absolute value of -3 plus 2. Now if we work that out, the absolute value of 3 is 3 plus 2, and that's 5. So I have to plot that point now. -3, 5 would be up here, right? -3, 5. And let's do the same thing for -1. Absolute value of -1 plus 2. Okay, we take the absolute value first. That'd be 1 plus 2, which is 3. Okay, so now I have the point -1, 3. Okay, -1, 3 would be right there. And let's continue with the table. If I put 0 in here, that's basically going to be absolute value of 0, 0 plus 2. That would be 0, 2. 0, 2 would be right here. And then let's see what happens with 1. If I put the absolute value of 1 plus 2, that's 1 plus 2, right? Absolute value of 1 is +1 plus 2 is 3. Now I have 1, 3. And then if I did the same thing for 2, I'll go ahead and tell you that that works out to be 4. 2, 4 is right there. And this is the graph here. Now we need to make, again, please use a straight edge for these lines. Now this is the absolute value of x plus 2. Now here's the deal on this. What you have to be able to do is find and identify this point. This we're going to call the key point. All right, in my parent function, the key point was on the origin right here. This is the key point. All right, and finding the key point is going to be the key to you being able to do this easily. Now let's look at what happened to my key point on number 2 compared to the parent function. When I added this plus 2, notice the parent function key point was right here on the origin. Okay, it went up 2 places. Okay, so this plus 2, now notice that plus 2 is not inside the absolute value. It was outside the absolute value. Okay, the key point moved up 2, or we could say plus 2 on the y-axis. And that will happen every time. If I add 2 outside of the absolute value, it's going to move it up. What do you think is going to happen if I go minus something? Hopefully you're thinking it's going to go down the y-axis. Okay, so that little hint right there will help me to identify that key point. The reason that's the key point is that's where that shape changes directions. Now, when you graph absolute value functions, you're always going to get this kind of a shape, this kind of 90-degree angle. Okay, there are times when it can go down. We'll see that later, but you're never going to get a straight line on absolute values because of what absolute value does by making the values always positive. Okay, so let's keep that in mind. So anytime we add a number outside, you want to remember that rule there because that's going to make our lives a lot easier. If we add a number or subtract a number outside the parenthesis or outside the absolute value, it's going to move it up or down. So let's look and see what happens on number 3 here, keeping that in mind. Now let's look how this one's different. This one is different because they're adding 4. Okay, they're adding inside. Okay, so we want to know, well, how does that compare? How is that going to change our graph compared to the parent function if we add inside? Because on number two, they added a number outside. And these patterns are what you're going to have to be able to identify, all comparing back to what happens compared to the parent function. So let's plot the points here and see. Because if you get these rules down on these patterns, you actually can graph these without doing all of these points. You can cut those in half. Now I'm going to, I wish I had written this table down here. So you might want to do that because we're going to need a little more space. Let's put this table down here. Okay, and watch what happens. Okay, this will be x and that's y. And I'll just use the values that I had picked here. -6. If x is -6, here's how we work this out. Using this equation, y is equal to the absolute value of -6 plus 4. Okay, that works out to be, now you have to simplify inside there. You're going to get the absolute value of -2, which equals +2 after you take the absolute value. So that is the point -6, +2. So you have to plot that point out here. All right, that's that point done. Let's try -5. And if I did the same thing for -5, it's the absolute value of -5 plus 4. That's equal to -5 plus 4 is the absolute value of -1. That works out to be +1, so that is -5, +1. All right, let's try -4. And we'll do the same thing, -4 plus 4. Oh, that's easy. That's just 0. And I know the absolute value of 0 is 0. And now let's continue with -3. I'm just working down my list here. -3, absolute value of -3 plus 4. That'd be the absolute value of +1, which is also +1. -3, look what happened right there. Did you see it? It turned. And I'll go ahead and give you the last one. -2 works out to be +2. All right, so we end up with this shape right here. Connect it with a straight edge. Now, how does this compare to the parent function? This time, if we look back at number 1, again, the parent function key point is on the origin, okay? So in this one, my key point is -4, 0. All right, so when I added 4 inside, it moved left 4 spaces. All right, in other words, it went -4. X went -4. Okay, so X was -4 on that key point. So notice when it added 4 inside, it did the opposite direction along the X-axis. Okay, so with that in mind, so now we know if I add a number inside the parenthesis, inside the absolute value, it's going to move it on the x-axis the opposite direction. Because plus 4 is actually over here, but it goes the opposite direction. But if I subtract or add outside, it goes up and down the y-axis the same direction. So I'm going to stop this video here and continue on the next one, and we're going to use that information to identify key points and hopefully shorten up the process of graphing these graphs. So we'll stop this one and continue on with part 2 next.